So now let's switch gears and talk about a Coalesce system, and we'll dovetail into a dehydrator. What are the advantages of a Coalesce system, and then what are the disadvantages, including the limitations on the oils that can be used for coalescing?
I think the biggest advantage to Coalescer is the ability to remove massive amounts of free water very, very quickly.
Yep.
And mechanically, they're fairly simple. So as far as moving parts, you have electric motor and a pump, and then you have some valves that need to open and close. So advantages, gross free water, very, very rapid removal.
As well as particulate filtration.
Yeah, but as far as disadvantages, they only remove free water.
Only remove free water, that's right.
They only remove free water. They can only be applied to lightly additized lubricants, turbine oils, compressor lubricants, or those R&O lubricants as we call them. But they're also, coalescence is also viscosity limited. To get the full single pass efficiency of coalescence, your viscosity needs to be at or below 32 centistokes, 150 Saybolt seconds, and it works pretty well in the terminal industry. We're using mostly 32 and 46 R&Os, but in some of your heavier fluids that operate at lower temperatures, the viscosity of those fluids are so high that you lose efficiency. In a perfect world, or in say like diesel fuel, that's really a low viscous fluid, it can remove 99% of free water on a single pass. But
Yep.
As viscosity increases, water removal efficiency decreases, and like both of you mentioned earlier, we're only affecting free water.
Well, and one other thing that we've really started to see the last few years, even if everything's perfect, you've got an ISO 32 R&O turbine oil, temperature's good, everything's good. If that oil's deteriorated, if it's been if there's oxidation going on, a small amount of oxidation byproducts can negatively affect the ability for the coalescer to remove water. So I think talking about demulsibility is probably a little more in depth than we want to have in this conversation, but that oil needs to be in good shape. It needs to be in good condition. So it is limited in that the oil, it doesn't necessarily have to be pristine, but the oil has to be in fairly new condition for it to work. Now diesel fuel doesn't matter, but as far as lubricating oils, if you start losing demulsibility, the system's not going to work.
No, I mean, water as a chemical compound is polar. Lubricants, as a rule, are nonpolar, so you can't mix a polar and a nonpolar compound into a true solution. But with the presence of contamination within your lubricant, it could be oxidation byproducts, like you mentioned. It could be an accidental cross-contamination with a lubricant that has detergents or some anti-wear type additives or extreme pressure additives.
An assembly lube. If they did somebody rebuild a pump and used assembly lube.
Any contaminant that has polar compounds is going to affect the fluid's ability to shed water as a polar compound, because polar compounds will try to stick together.
Yeah, the one thing to think about when you're looking at, or one of the things to look at with coalescing, is it's a mechanical separation. So it's dependent on the properties of oil and water being different.
Correct.
If you don't have if you don't have some, or I guess I say, if you have something that is going to cause that to be compromised, it's not going to work.
Yep. So AW, anti-wear additive package, very aggressive. I can't coalesce water out of that type of oil. Extreme pressure, EP additive, very aggressive. It's going to adhere itself to the coalesce media. So we know there's some limitations there. The advantage compared to water absorbing is it continues to shed. So that's
Correct.
good. So the cost, once you purchase it, it's very low. But there is another limitation. Because it's only free water, what do we recommend for our customers as far as the temperature at which they need to coalesce? Higher, lower? What's your thoughts on that?
Well, typically we need to coalesce at a fluid temperature where the viscosity is at least no greater than 32 centistokes, which happens to be where most the lubricant used most often in turbines and compressors. But since those systems tend to run at elevated temperatures during operation of the system, you are raising the saturation point of the fluid, so you're allowing the fluid to operate at a higher water content with the dissolved water that's remaining.